Alright, questions 21 through 25. How does the radioactive isotope C14 differ from its stable counterpart C12? First of all, somebody was asking, this is isotopic notation. Okay? What do those numbers represent? Mass. Are we changing elements?
No.
Same element. So if it's the same element, it's the same number of protons. What are we changing if we change mass? Neutrons, yes.
Is that the atomic mass or the molar mass?
That is the atomic mass for that particular isotope. It's not the average atomic mass. Okay? So it will have the same number of protons, same atom, same element, but 2 more neutrons. 22, compound, has 50% sulfur and 50% oxygen. Do oxygen and sulfur have the same molar mass?
No.
No. Oxygen's molar mass is roughly 16. Sulfur is roughly 32. Double that of oxygen. So if they each represent 50% of the mass, you have to have 2 atoms of oxygen for every 1 atom of sulfur.
So it's J.
No, it is J.
Oh,
okay. Does that make sense?
Wait, so you have to have...
Because oxygen is 16 grams, roughly 16 grams per mole, sulfur is 32 grams per mole.
Twice.
If they each represent 50% of the mass, you're going to have 2 atoms of oxygen for every 1 atom of sulfur. That would be the ratio. All right, 23. An experiment yielded the above temperature and time information. They want to know the freezing point if we start at time 0 as a solid. Okay, freezing point is going to be your first plateau, which is here. So our freezing point is 0 degrees.
Interesting. Good job, Anise.
24. How many had difficulty with this one? All right. How many milliliters of 2 molar solution? Well, if we know if it's a 2 molar solution, we've got 2 moles in a certain volume to provide 0.25 moles of H2SO4. So we want to know, we want to get to that many moles, and we want to know what volume that's going to be. Correct?
Yes.
All right. So let's go ahead and switch these 2 variables. So X milliliters will be equal to 0.25 moles divided by 2 moles.
0.12.
Would it just be like
0.125 is how many liters there are. 2 liters. So you do 1,000 things, you get 125 milliliters.
How's that going to be milliliters though? Because you're dividing moles by moles.
No.
It's molarity. Okay.
What does that mean? So when it's molarity, you don't take it to liters?
This is going to be 1,000
1,000?
milliliters. Oh,
Braces.
because it's 1 liter. Okay. So you're going to multiply this also by 1,000 to get milliliters.
Oh, I'm confused. You did take it to liters.
Does that make sense?
Yeah.
Because I go,
Okay. Because molarity is 2 moles over 1 liter. 1 liter is 1,000 milliliters. So you are just going to be doing a little bit of algebra to isolate this on one side.
So would you always do that in this type of case?
You're not changing the amount of solute, you're just changing the volume. Okay? So they're going to be equal.
oh, I see. Okay.
They're going to be equal. 2 moles is in 1 liter, 4,000 milliliters. 0.25 moles for X milliliters.
Exciting, right?
We good? Okay.
Exciting.
Last one for this one. Reaction shown above.
Exothermic.
Do we have heat entering the equation or exiting?
Exiting.
Thank you. So it is exothermic reaction.